So I'm going to show you how to do the next step, which is a little bit something old and a little bit something new. We're going to be using grams to calculate molarity. In order to do this, we have to know how many moles we have, because molarity is moles divided by liters. So to do that, we're going to use one calculation we learned a long time ago and one that we just learned. So let's say we have this problem. What is the molarity of a sodium chloride solution containing 60 grams of solute in 0.01 liters? Well, the problem with this for us as it stands right now is that we were given our information in grams, and we know we are going to need that information in moles. So the way we're going to do that is we're going to use the formula moles equals grams over gram formula mass. This is the mole calculation. You can find it on table T, just above where you have your concentration calculations. So what are the steps for this? Well, the first thing you'll do is as we always start out, write out your formula to find all your known and your unknown variables. Then we're going to convert our grams into moles, which is very simple, and I'm going to remind you how to do that. And then step 3, we're going to plug our numbers into the molarity formula and solve. So let's do an example together. So we are going to calculate that molarity of a sodium chloride solution that has 60 grams of solute in 0.01 liters. So the first place I have to start is to calculate my moles. So I remember that moles equals grams over gram formula mass. My grams here are 60 grams. I need my gram formula mass, however, and the way I'm going to do that is I'm going to use the atomic mass for sodium and chlorine, add them together to get my overall mass for sodium chloride. So I'm going to round everything to keep things a little bit more simple here. So I've got my sodium, I have one of them, I have my chlorine, I have one of those. My sodium is 23 grams. My chlorine is 35.5 grams. This gives me a total mass of 58.5 grams. So that will be what I put right here. Okay. I'm going to just change my ink color for you for a second, make things a little bit easier to see. So I've got my 58.5 grams per mole. And when I calculate that out, 60 divided by 58.5 is going to give me, oh, I need a calculator. This is one I'm not going to do in my head. Okay, so 60 divided by 58.5 gives us 1.025, so I'm going to round that to 1.03. So we have 1.03 grams in 1 mole. So that's where we are at the moment. Now we know how many moles we have. So we are going to take our moles, put it into our molarity formula, 1.03, and we are going to divide that by our 0.01 liters. And that is going to give us a molarity of 102.56, which would round to 102.6, and that would be moles per liter, would be our units for molarity. Okay, now let's say that we've got a situation where we have been given the number of milliliters or liters, and we've been giving a molarity. How can we figure out how many moles we have? Well, that's a different situation. We're going to work backwards. So here we're going to solve for grams, okay? And we've been given milliliters and we've been given molarity. So the first thing we are going to do is we are going to calculate our number of moles and then go from moles back to grams. So I have a 0.4 molar solution We don't know how many moles that is, but I know I have 300 milliliters, but wait, hold on. We can't use milliliters because this is a molarity calculation. We have to use liters. So 300 milliliters would equal 0.3 liters. Now we can do our math, and that means that our moles equal 0.4 times 0.3, which will give us 0.12 moles. Now, I can use that in my moles to grams, because I know 1 mole equals grams over gram formula mass. My mole is 0.12, and my grams, I don't know, but lucky for you, I used the exact same substance that we used in our previous problem where we calculated out our gram formula mass at 58.5 grams per mole. So to solve this, we will take 0.12 and we will multiply that by 58.5, and that gives us a number of grams of 7.02. So our grams are 7.02 grams.